All right. Today we're going to graph sine and cosine and tangent functions, and then we're going to include some translations. We've actually taken the reflections out now, so we don't have to do reflections anymore because they are no longer on the test or in the standards. So just translations. So here are the transformations of sine and cosine. We know what A does, that's our amplitude. And then we know what B does, that shifts our parent function. The other transformation we're going to focus on today is the K transformation, which is a vertical shift. We're not going to see any H's. H shift from left to right. In sine and cosine, we're not going to shift left or right. We're just going to shift with the K, which is on the outside of the parentheses. So if you have a plus K, you're going to shift up. If you have a minus K, you're going to shift the whole graph down. So sometimes there's an H, and if you take trig, you'll maybe do some more advanced shifts involving the H, but we are only going to shift with the K, the vertical shift right now. Okay, so let's first talk about the amplitude, the period, the translation of the following trig functions. So translation is the word we're using for shift. So my amplitude is your leading coefficient. That's going to be your A value. So this one has an amplitude of 4. The period for sine and cosine is found by taking 2 pi over B, where B is the value in front of the x. So in this case, B would be 1. So our period is going to be 2 pi over 1, or just 2 pi. So then the last thing we're going to talk about is the translation. And that's our K value. That's the only difference from the ones we just did. And these is that it has a plus 5 at the end. So this translation, plus 5, means that the graph is going to be shifted up 5. Good? All right. For the next one, amplitude is our leading coefficient, which in this case is 1/2. Amplitude here is 1/2. Then the period will be 2 pi over B, which in this case, that B is the number that's in front of the x. The last one had no number in front of x, so we assumed that it was 1. This one has a 2. So our B is 2, so 2 pi over B is equal to 2 pi over 2, which is pi. And then the other difference here is that we have a minus 9 at the end. The minus 9 becomes your translation. So translation is -9, which means you're going to shift the graph down 9 units. Otherwise, it'll be graphed the same way as before. All right. So let's graph the sine, and we have a shift of 5. So what we're going to do is we're going to graph the parent function. We're going to graph just sine of x, whatever we have in front. The last thing we're going to do is do the shift of plus 5. We're going to take every point and just move it up 5. So if I just want to graph this section first, your amplitude will be your leading coefficient, which is 1. The period, which is 2 pi over B, so just 2 pi over 1, so 2 pi. And we'll start with that. So if this is 2 pi, then we divide that in half. 2 pi times 1/2 will be pi. Then for this one, you take pi times 1/2 again, so pi over 2. So that tells me what I'm counting by now. I'm counting by 1 pi over 2. So the next one is 2 pi over 2, which reduced 2 pi. So then my third mark here is going to be 3 pi over 2. So 3 pi over 2. And then 2 pi, which is 4 pi over 2. I'm counting by 1/2 pi's. So getting the period is definitely the hardest part. So I started with 2 pi, cut that in half, I got to pi. Cut that in half again, I got to pi over 2. Then I was counting by pi over 2's to get the third mark. All right, so we're going to use our unit circle to decide which values of sine and cosine we have. This point is 1, 0. We have 0, 1, negative 1, 0, 0, negative 1. Cosine is my x value, sine is my y value, so sine starts at 0, and we go counterclockwise. So I'm going to put 1 right here. Since we do have to shift it up 5, we're going to end up going up quite a ways on this. So I'm going to make 1 there, negative 1 here. So sine starts at 0. I get that from this point right here. Then we go to the right, counterclockwise, we go to 1. Then we go down to 0 again. Then we go back to negative 1. Then we go up to 0. I'm going to do this in a dashed line because this is not my whole function. I've only done the sine of x. I still have to do the plus 5. So we're going to do that in dashed, because that is not my answer, okay? So now I need to translate plus 5, which means you need to translate the whole graph up 5 points. So I'm going to take each point and move them up 5. So I need to continue my scale here to go 2, 3, 4, 5. I think we got to go all the way up to 6. So then you take each individual point. So I'm going to start with this point right here at 0, 0 and move it up 5. So 1, 2, 3, 4, 5 puts me at 0, 5. Then at pi over 2 we're at 1. So at pi over 2 I'm going to move this point up 5. 1, 2, 3, 4, 5. It's going to be pi over 2 and 6. Get questions, you can ask, it's fine. Because it started at 1 and our shift is plus 5, so that means I had to do 1 plus 5, put me up to 6. Now we're at 0, and so if I move up 5, I'd be at 5 again. So pi, it'll be at 5. Then at 3 pi over 2, right now it's at negative 1. If you move it up 5, it should be ending at 4. So negative 1 moved up 5 will be at 4. And then 2 pi, we're at 0, so move it back up to 5. So this is like the new middle of the graph. And this is the curve. So the solid line will be your final answer. The dashed line will be your parent function. Yeah, but then it like... Okay, well, apparently I wasn't recording that whole thing, so we're just going to throw that out there, but quick recap. We graphed it in orange first with the purple dash line. What I underlined up here in orange was our first thing that we graphed. They had an amplitude of 1/2. Period was 2 pi over b, which is right here, which gave us a period of 2. So we put that on the x-axis. Then we graphed cosine normal with our dashed line. Then we did our translation in blue of plus 3 since we were counting by 1/2, so we moved each point up 1/2. All right. You'll just have to ask questions if you got them. We're going on. This is very similar to the example we just did. Should we do it again? What do you guys think? All right. We'll get this one recorded this time. Okay. If this isn't flashing, I'm not recording, so let me know. Okay. So this time, this is our original graph. We're going to graph that part first. Then we're going to move it up 4. Okay. So my amplitude is 1/2. Period for cosine is 2 pi over b, which is 2 pi over 1, because b is just 1 right here. There's nothing in front of the x, so 2 pi. That's on my x-axis. I'm going to end at 2 pi. So then you have to figure out what's halfway between 2 pi. So take 2 pi times a half, and you get 2 pi over 2, which is just pi. Then for this mark, you take pi and times it by a half again, so you get pi over 2. And that should tell you what you're counting by. So what are we counting by? 1 pi over 2. So this is 1 pi over 2 here. 2 pi's over 2 for the second mark, which is our pi. The last one, the third one, will be 3 pi over 2. And then we have an amplitude of 1/2. So along the y-axis, I'm going to count by halves. So 0.5, 1 point, or 1 point, just 1. 0.5, 1, 1.5, 2, 2.5. I think we got to go all the way up to 3 because we got to move it up 4. And then we got negative 0.5 down here, negative 1, negative 1.5. That should be good. I'm going to graph the original in red. So we got 1, 0, 0, 1, negative 1, 0, 0, negative 1 on my unit circle. Cosine, sine, it goes in alphabetical order. So cosine is my x value. So I start at 1, which is actually 1/2. Then cosine goes to 0. Then cosine goes to negative 1, which is actually negative half. Then it goes back to 0 again. Then to complete the circle, cosine goes back up to 1, which is 1/2. So dashed line for that one, that is just the what's boxed in orange. We still have to do the translation, which is +4, which means I'm going to take every point and move them up 4 places, which is really moving them up a half every time because we're counting by a half since our amplitude was a half. Do that in purple. So starting at 0.5 and moving up 4 places. 1, 2, 3, 4 puts me at 2.5. Starting at 0, moving up 4, there's 1, 2, 3, 4 right there. This one's starting at negative 0.5, so 1 will be at 0, 2, 3, 4. Starting at 0, moving up 1, 2, 3, 4. Then starting at 0.5, moving up 1, 2, 3, 4. And then that will be our final answer. Okay, you can shift down. All 3 of these examples happen to be shifting up, but we can shift down. So let's find a tangent one where we shift down. So we'll come back to that one if we have time. Let's do this one. So we can graph and tangent with transformations as well. Be the same idea is that we're going to graph this part first. Then this is our translation. So this says we have a translation of -1, which means when we're done, we're going to move the whole graph down 1 unit. So to begin, just this orange circle or the square here, just graph this part. We have an amplitude of 1/3. The period for tangent is a little different than sine over cosine. Instead of 2 pi over b, tangent is pi over b. So that's one thing you really have to remember. Since our b value is the number in front of x and there is nothing, we have to assume that it's 1. So our period will be pi over 1, which is pi. So let's draw some xy axes here. We'll go like this, go like that. So this is x, this is y. Now we're going to have force on either side of the x or the y-axis, so I'm going to count by 2s. I have a tick mark here and a tick mark here. Then I have one over here and one here. Now my asymptotes are going to be at the very outside of that. So I'm going to put those in there right away. So tangent is divided into force, but the y-axis is in the middle. So my 0, 0 point is my middle point of my tangent curve. Then I have two asymptotes on the right and on the left. To find those asymptotes, since this whole from asymptote to asymptote is our period of pi, to find our asymptotes, we have to take that period and multiply it by a half. So we're going to cut it in half. One for the positive distance right here, and one for the negative distance right there, from 0 to positive, 0 to negative. Okay, so our period is pi, so pi times 1/2 is going to be pi over 2. So one asymptote will be pi over 2, the other asymptote will be negative pi over 2. If you're super confused right now, it's because you were probably gone Friday and this is what we did. Then we have to find those other dash marks, those other purple dash marks. And so this is 0 right here. So halfway between 0 and pi over 2, you're going to take that pi over 2 and cut it in half again by multiplying by a half. And you're going to get pi over 4, which means this one's negative pi over 4. Then our amplitude is going by at a third. So let's make this 1/3. Then we're counting by thirds, so this will be 2/3. This will be 1. So negative 1/3, negative 2/3, negative 1. I'm going to do the original graph in red here. Actually, I'll do it in orange. So what I've boxed in orange here. Tangent of 0 is 0. Then at my pi over 4, I'm going to have an amplitude of 1/3. So my original graph is going to be right there. Then at negative pi over 4, my original tangent will be at negative 1/3 based off of my amplitude. So here's my original tangent. If we were just graphing what's boxed in orange, we're done. The last thing we have to do is that translation, which says that the whole graph has been moved down 1 unit, which means you're going to take each dot and move it down 1. I'll do that one in red. And since we have an amplitude of a third, we're counting by thirds. So the point that's at 0 is going to go down to negative 1/3. The point that's at 1/3 will go down to 0. And the point that's at negative 1/3 will go down 1 to negative 2/3. And this is the graph of that shifted down 1. Make sure that as you draw your curves, you're going to get really close to that dashed line, but you're not going to cross it. And both sides. It's going to approach positive infinity as you go to the right, and it's going to approach negative infinity as you go to the left, but it will not cross those asymptote lines.